Okay, so this is the 2-5 notes, graphing quadratic functions and finding their domain and range. I've got this mostly filled out, so I'm more going to be interested in showing you what to do on your calculator than I am to worry about filling this in. The most important thing is when you're looking for your range, figure out if you have a minimum or maximum. If it's a minimum, your equation will be y is greater than or equal to whatever the minimum is. If it's a maximum, y will be less than or equal to whatever the maximum is. So the best thing to do is to graph everything. So we're going to go in and we're going to graph the equation. No matter how complicated it is, this will always work. So we're going to put in everything after the equal sign. Okay, and we see our graph. Now it asks us to fill in the table. The best way to do that is to push menu, go to table, which is 7, and do a split screen so you can still see your picture of your graph, but also see the table. The numbers on the very edge here, those are your x's. Those are the same as here. So we just need to go up and down until we find 1, 2, 3, 4, 5, which just happens to be on the screen. The second column is, notice it has the equation there. Means that these are your y's. So for 1, there's 6, 3, or excuse me, 2 is 3, 3 is 2, 4 is 3, and 5 is 6. Okay, so looking at our graph, you can turn the split screen off by doing Control T for table, and you can actually zoom in, or I can zoom in, to the graph, and you can see that this is definitely at axis 3, our lowest point, our lowest y is at 2. So that's a minimum, and that's why our equation ends up being y is greater than, because it's growing away from 2. It's growing up. Okay? Next question on here is showing another graph, and I apologize for this zoom. So we're going to go back to new and start with a new graph so that we do not have confusion with what's on here. Push in negative x squared plus 4x plus 1. And you'll know this time it looks like a frowny face. How do I know it was going to be a frowny face ever before doing that? If there's a negative number in front of the x squared, it will be a frowny face, which means you have a maximum. If it's a positive number in front of the x squared, that means that it is a positive and happy face, and you'll have a minimum. So that's a little clue. So this is a maximum at 5. Domain for all quadratics is always all real numbers unless it's a specially drawn one like we have on the very bottom of this paper. So our domains will always be all real numbers. What we'll have to just distinguish is our maximum and mins. And here's where you see a maximum is all numbers that are less than 5. So everything's growing up, but it's only growing up to number 5. At 5, it starts the next one, it just starts dropping down. So it's growing up to 5 and then going down to 5. So everything, all the y's have to be less than 5. Okay, on this one, they don't have an equation, but you can see the numbers being grown that's happening. It's going from negative 1 to 2 to 3, and then we have a repeat coming 2 and 1. When you are seeing it on a table, look for the repeats. Look for where a number is surrounded by the same number on both sides. That's going to be your clue. If the numbers are smaller than the number being surrounded, then it's a max. If they're bigger than the number around it, it's a minimum. So because it's a max, its y is less than or equal to 3 for the range. Okay, so here's an example of a min. You look for the two numbers being repeated around something. They are bigger numerically. -1 is bigger than -2, which means you would have had at -1 and -2, you would have had this happening, that situation happening, which makes it a max, so you have greater than -2. Here we have -8, which is bigger than -9 because they're negatives. You got to remember -8 is bigger than -9. So again, at -8, it's going to be a higher point than -9 would be. Okay? So that is also a minimum. And again, all real numbers for all domains. So here we have a situation where we have the graph. We can see a max. And the max this time is at y is 0. So we're looking at what number is on that y-axis to determine what is our answer. So y is less than or equal to 0. Now the last one that we have is actually a stunted quadratic. There's limitations on it, both on the domain and on the range. So it's not an arrow on both sides. So we have a domain that's going to be from, where's that point? When you're moving left to right, it's at -3. Keep going left to right, and the last place we see a point is at +2. Here, there's a closed dot. That makes it an equal sign. This one is an open dot, which makes it not equal to. For range, we start at the bottom. The first thing we see is the minimum, which is at -7. And then it's growing, and it's growing, and it's growing, and it stopped. Nope, it's still growing. It's still growing. It's still growing. It's still growing. Gets to 2. Okay, just because this one didn't go all the way up doesn't mean that the rest of it didn't go all the way up. Remember that the whole graph is what you're looking at when you're talking domain and range. And those were both dotted points, which means they're equal to. Okay, that is all of the 2-5 notes.